Okay, welcome back. This is Mr. Hassan's Maths channel, and I'm now answering a question from the October-November 2022 Cambridge paper 3. This is a pure mathematics 3, paper 3, variant 3. It's from the 9709 syllabus. This question is question number 7, which is about this trig equation, root 5 secant x plus tan x equals 4. And we need to show that it can be rewritten in the form r cosine plus x plus alpha. R cosine x plus alpha equals root 5, where r is greater than 0 and alpha is between 0 and 90 degrees. It's an acute angle. Give the exact value of r. So r should be given in terms of an exact value, and alpha correct to 2 decimal places. Okay, so now this question would have thrown a lot of the students off, as it did in the test that I gave. All right, because we're not used to seeing something like this, which has secants and tans, needed to be rewritten in the form of r cosine x plus alpha. Okay, if you got to write something in terms of r cosine x plus alpha, we have to think about the addition formulae. And the addition formula that fits with this is the one that says cosine A minus B. So I have the formula here from the formula sheet. This is a formula that we need to apply in this situation. Okay, so now, how do we, get this to look like something where you're going to have a cosine x and you'll need to have a minus sine x. We need to have cosine x minus sine x. Something cosine x minus something sine x. That's how we need to rewrite this. Okay? So in order for us to rewrite this in a form such that we'll end up with cosines and sines, we need to change. We need to use some of our identities to change it. So I know that secant x is a reciprocal, the trig function for cosine x. So this is the same as 1 over cosine x. So I'll rewrite this as root 5 divided by cosine x. And I know that the tangent of x can be expressed in terms of sines and cosines, because tan of x is sine x over cosine x. Okay, so now we're getting something that looks a bit more familiar, except we've got this fraction. So we don't have fractions here. So let's get rid of the fraction. Let's multiply both sides of this by cosine x. So multiply both sides of the equation by cosine x. The cosine x cancels when it multiplies with this. Okay, the cosine x multiply all of this side. This becomes root 5. This becomes cosine x is cancelling with that. It gives you plus sine x equals, and this will be 4 times cosine x. Okay, now it's kind of looking a bit more familiar, but I want to have cosine x minus sine x. So if I subtract sine x from both sides, this side is left with root 5. I've got 4 cosine x minus sine x. So we have now expressed it in the form that we need to. So we can say that 4 times cosine x minus sine x equals root 5. Now, this is something I can work with. Okay, I can work with this because now it's in this type of form here. And then I can deal with, rewriting it in this form here. Okay, so I've got to rewrite it in this form here. So what I'm going to do now is I'm going to just take that part here. I'm going to say that 4 cosine x minus sine of x is equal to, we have to rewrite it in the form, r cosine x plus alpha. R times cosine in brackets x plus alpha. Okay, now what I'm going to do is I'm going to use this expansion that we have here. Okay, I'm going to use this expansion to rewrite what we have here. So I have 4 cosine x minus sine alpha minus sine x, 4 cosine x minus sine x is equal to r times cosine x cosine alpha. It's like my x is the a and the alpha is the b, right? So r cosine x plus alpha. R cosine x times cosine alpha. Cosine a, cosine b. And the r is just multiplying the whole thing. And when there's a plus here, then there's a minus there. If I put minus, I'll have r times sine x times sine alpha. Okay, the x is like the a there and the alpha is like the b there. Now what we need to do is we need to compare the coefficients of both of these sides in order to find the value of r and the value of alpha. So I'm going to compare the coefficients first of cosine x. So on this side I've got cosine x, and this side I've got cosine x. This is an identity basically. These two sides are identical to each other. And I can say that the coefficient of cosine x on this side, so I've got cosine x, I'm comparing the coefficients. The coefficient of cosine x on this side is 4, and that must be equal to the coefficient of cosine x on that side, because this and that must be equal to each other. So that means 4 must be the same value as r cosine alpha. All right, and I can do the same with sine x. If I look at the coefficients of sine x on both sides, okay, I can, for example, I can have a look at here I've got basically sine x, here I've got sine x. Okay, the coefficient of sine x on this side is 1. It's like 1 sine x. There's a minus here and then minus here, so I don't have to worry about the minus sign. So there's a 1 here, it's 1 equals, and on this side I've got r times sine alpha. So r times sine of alpha. So from this, I can say that cosine of alpha is equal to 4 over r. And from this, I can say that the sine of alpha is equal to 1 over r. And I can form, from these two together, I can form a right angle triangle. I can say if this is alpha, then cosine alpha is adjacent over hypotenuse. So this is 4 and this is r. And the sine of alpha is opposite over hypotenuse. So that's 1 over r. So from this, I can work out the value of r. So from this, I can work out the value of r. I can say from this that r is equal to, or I can say r is equal to, by Pythagoras, the square root of 1 squared plus 4 squared, which is root 17. R is an exact form, so we leave it like that. So that's r. R is equal to the square root of 17. And for alpha, I can say that the tangent of alpha is opposite over adjacent, 1 over 4. So therefore, I can say that alpha is equal to inverse tan of a quarter. So alpha is going to be equal to what? Take our calculator. We'll do inverse tan in degree mode. Yes, it has been degrees. Inverse tan of a quarter. The question states the answer in degrees, so we put it in degrees. So inverse tan of a quarter gives us 14.0362. 14.0362 degrees. And the question states, I think, 2 decimal places. All right, if it didn't say anything, we know it should be to 1 decimal place because of its degrees, but the question states otherwise. So 2 decimal places for the alpha. So that should be 14.04. So alpha is equal to 14.04 degrees. All right, so there's alpha and there's r. Now, what I suggest we do, because it says here, it says, show that the equation can be expressed in this form. So don't just write down the value of r and the value of alpha. Rewrite it in this form. Okay, so we can say, therefore, that the equation root 5 secant x, what was the rest of it? Plus tan x equals 4, plus tan x equals 4. We can rewrite this. Okay, we can rewrite this as in the form r cosine x plus alpha. So r cosine x plus alpha, so root 17 is r cosine x plus alpha, which is 14.04 degrees, is equal to, okay, and it says is equal to root 5. is equal to root 5. You see here. Okay? Equals root 5. That's what we got there. Equals root 5. All right. So this is something that we, had to show that this equation, we rewrote it in this form. Okay? And that's exactly what we had to show. R cosine x plus alpha equals root 5. Okay, good. So we got the answer to this question, part A. All right, so this was a question in which many students didn't know how to proceed, because normally the question is given already in this form. It will say, show that 4 cosine x minus sine alpha is equal to the form r cosine x plus alpha. That's how the question would start. Okay, in this question, we had to start with something that didn't look like this at all. We had to rewrite it and put it in this form. So that's what threw people off, a few of you students off in this question. Right, now for part B, we're going to, I think, use the answers that we've got to do something else. So it says, hence, solve the equation root 5 secant 2x plus tan 2x equals 4 for x between 0 and 180 degrees. Okay, so the word hence means use the previous answer. So we go back to the previous answer and we're going to use that to solve this equation. Okay, so now I'll get the previous answer back up here. Okay, so this is the previous answer. This is the answer to part A. Okay, it says we took this and we rewrote it in this form, and we're going to solve this equation. Now the thing is, you have to be very careful. A lot of students didn't notice this. This is 2x. Okay, this is 2x. These angles are 2x, and these angles are x. Right? So what we have to do is we have to take care. We can rewrite this in this form. So we can say that root 5 of secant of 2x plus the tan of 2x is going to be the same. Well, we can rewrite this as root 17 times the cosine of 2x plus 14.04 degrees equals root 5. All right, so we can rewrite this in this form. Remember now, this is 2x, that's going to be the angle. So whatever angle is here should be the same angle there. So if this is x here, that will be x there. If this is 2x here, this will be 2x there. All right, and that makes a big difference, of course, to the answer. So we have to solve the equation root 17 times the cosine of the angle 2x plus 14.04 degrees is equal to root 5. So to solve this equation, and we have to solve this between the limits of 0 and 180 degrees. All right, so to solve this equation, what we must do first is isolate this cosine 2x plus 14.04. So we're going to divide both sides by root 17 first. So we have the cosine of 2x plus 14.04 degrees is equal to the square root of 5 divided by the square root of 17. And to find the solution, first we'll get the principal solution, which will be inverse cosine of both sides. So inverse cosine of this side gets rid of the cosine, and the inverse cosine of this side, inverse cosine of root 5 over root 17. What will that give us? Well, let's have a look. Take a calculator. We have to be in degree mode. So we've got inverse cosine of root 5 over root 17. Root 5 divided by the square root of 17. And that will give us 57.1578. So that's going to be 57.1578 goes on. All right, so that's 2x plus 14.04 degrees. Now, we have to get all the angles within our range. All right, now our range is for x between 0 and 180. Now, the angle that we are dealing with here is 2x plus 14.04. Right, so we have to adjust the range to match this. So I have to change this to 2x plus 14.04 degrees, in which case this becomes 2 times 0 plus 14.04, which is 14.04. 0.04. And this becomes 360. 2 times 180 is 360 plus 14.04. That's going to be 374, sorry, 0.04. Let me just write that in a neater way, because it's going to be 360 plus 14.04. So that's 374.04 degrees. So we have to catch all the angles within this range, okay, for this. So we know that for the cosine curve, you have the principal solution and you have 360 minus the principal solution. So I'm going to also have 360 minus 57.1578. So I'll take my answer and I'm going to do 360 minus the answer, which gives us 302.842. 302.842 degrees. Now what we have to do is we have to find the x, because there's no other solution within our range, because these solutions, all the other solutions will be separated from this solution every 360 degrees. The cosine curve repeats itself every 360 degrees. Okay, and why did I do 360 minus this? Because the cosine curve has a special type of symmetry like this, between 0 and 360 degrees. All right, we found an angle over here. The other angle is all the way on this side, which is basically, this is 57 from 0. This is 57 less than 360. From the symmetry of the cosine curve, the angle that the calculator gives you, 360 minus that will give you the other place where you get the same angle, the same ratio. Okay, for the sine curve, it's 180 minus that. And then after that, they repeat every 360 degrees. In this case, if you add 360 to these, you're out of the range. Okay, the range is 374, that side. And if you take away 360 from these, again, you're outside of the range. We have to start from 14.04. So these are the only two solutions. Now I've got to find what x is. So I'm going to take the solutions. I'll rearrange this equation. So I'm going to have 57.1578 minus 14.04 divided by 2. And I'm going to do the same thing to this. 302.842 minus 14.04 divided by 2. And that will give me the two answers that we need. So we'll take the calculator. So I've already got this in my calculator. So I'll take away 14.04 and I'll divide by 2. That gives me 144.401. 144.401. Okay, and then for this one, I'll go back and find the answer that I got for this. Okay, so I have got this minus 14.04 and divided by 2. That gives us 21.558. 21.558. So therefore, now how do we round this? Does it tell us anything here? Nope. Okay, so angles and degrees should be given to one decimal place. So this should be 21.6 degrees and 144.4 degrees. Okay, so those are our two solutions, okay, within the range for this equation. So we use the answer to part A in order to solve this. Okay, so those are the two answers. Okay, so that completes this question from the October-November 2022 paper 3, variant 3. Other questions from this paper can be found in the playlist that will appear over here at the end of the video. Other questions from the topic of trig equations and identities can be found in the playlist over here. I'll make a separate playlist also for the R cosine or R sine type of questions. I'll make a playlist here separately for that. And you can subscribe to my channel by clicking on this link. Thank you for watching and see you soon.